So go to the very first page of your packet. We're going to start by talking about similar figures. Now, similarity. We briefly talked about this before back in Unit 1. Specifically with a specific transformation that we talked about. So, what we learned about transformations in the last unit is that most of the transformations that we did would create congruent figures. All right? However, there was one that did not create a congruent figure. Does anyone remember which one that was? Dilations. All right. So dilations created similar figures. All right. So remember, congruent means same size, same shape. Similar just means same shape, not necessarily the same size. All right. So dilations produce a figure that has side lengths that are scaled by the same factor, which that's called our scale factor, and the angle measures are the same as the pre-image. So the angles are congruent. So if you think about it, that's why, you guys remember when we were doing the congruency postulates and I said that angle is not a congruency postulate? Why did I say that? So why is angle not a congruence postulate, Abe? Right, because angles can still be the same, but the side lengths can be different. Just because it's the same shape does not mean it's the same size. All right. So angle, which we'll learn in a minute, actually comes into play with proving similar figures. Now, if you have similar figures, first off, similar is shown by this sign right here. So just like how equal sign with a squiggle means congruent, just a squiggle, so no equal sign underneath it, that means similar. And it would help if I spelled things correctly. This is why I'm not an English teacher. Now, some features of similar figures is that all the pairs of sides are proportional. All right, meaning that they have the same scale factor. And all the corresponding pairs of angles are congruent. Now, if we look at exercise 1, it says use tracing paper to verify that all the angles are congruent. We ain't got time for that. I can assure you those angles are congruent. But which are my corresponding angles? So I know what to mark. So someone raise their hand and name me one set of corresponding angles. Odin. A and D is one. What's another pair? Eisen. B and E. So I'm going to use 2 ticks on that one. What's the last set? C and F. So all 3 angles are congruent, which just furthers the fact when they make the statement that triangle ABC is similar to triangle EF. So if you see 2 triangles with that squiggle in between, it just means similar. They're similar. So now we're going to find the missing side lengths. So we're going to find the length of AC and EF. So if this was, say, a dilation problem, what would be kind of your method of finding those missing sides? Say that one more time. That makes sense. Right, we divide the side lengths of the bigger shape by the smaller shape. Or in reality, it doesn't really matter which way you divide because it doesn't specify which is the pre-image, as long as you stay consistent with it. All right, so I'm still going to do bigger minus smaller. Not minus, divided by smaller. Now, I need to find that scale factor because that'll be the easiest way. So, what 2 sides would I divide by to get that scale factor that I can for sure use? A. D, E, and A, B. So I'm going to divide 14 by 7. because they're corresponding sides and they're listed on both triangles. So what will my scale factor be? 2. So 2 is my scale factor. So how can I use that to find EF? Multiply 8, which is its corresponding side, by the scale factor of 2. So EF is what? 16. So EF is 16. Now, how do I use that to find AC? Divide DF by 2. Why am I dividing instead of multiplying? It's the bigger one. All right. So 20 divided by 2, that's 10. So that's what AC is. Now, just for example's sake, here is another method. All right. The other method would be to actually set up the proportions. So I would set up my first proportion, which is the sides that I definitely have values to. And then I'll set it equal to another proportion. So let's say I was solving for AC. So I'll call that X. All right. So I have 20, which I'm going to put with a 14 because it's the same triangle. So make sure that you keep everything consistent. So if you do the big triangle on top, that means you got to do the big triangle on top for the other. All right. And then I'm going to put X on the bottom as a placeholder for AC. Now, you guys have been doing proportions since early on middle school, late elementary school. So what do you do to solve a proportion? Cross multiply. So that would be 14x is equal to 140. Then you just divide by 14. Do you not, in fact, still get 10? Yes. So that's the other way you can do it. That comes in handy when your scale factor isn't like a nice number, like it's a weird fraction or something. So I don't really care which method you use, whatever feels most comfortable to you. I will say cross multiplying becomes the easier method the deeper we get into it. All right. Now, they want to say give a dilation of ABC that would produce an image of A prime, B prime, C prime that is congruent to DEF. So how do you know it's congruent? Well, we already know what the scale factor is. The scale factor is 2. So I can say that the triangle A prime, B prime, C prime is equal to twice the triangle of ABC because that's my scale factor. So that means that triangle A prime, B prime, and C prime is congruent to triangle DEF because triangle DEF is also equal to 2 times the size of triangle ABC. And again, that one's just restating what we already did, pretty much, just in a fancy way. Now, the way we define similar figures is very similar to how we define congruent figures. All right. So, in a minute, we're going to learn about different postulates for congruent figures. Or not congruent, for similar figures. Because there are postulates just like there are for congruent figures. So, congruent figures, like we have our 5 postulates that we like. So, side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. There are also postulates for similar figures, just not as many. Now, we'll get to that in just a minute, but just so we note this, 2 geometric figures are similar if there exists a similarity transformation that maps one figure onto the other. So, for example, that can just be a dilation alone, or it can be a sequence that contains a dilation with a combination of one or more rigid motions. So remember, when we did composite transformations back in Unit 1, the figures stay congruent as long as all of the transformations that we did in the sequence are rigid motions. But as soon as you throw a dilation in there, it becomes a similar figure. All right? It doesn't matter where the dilation is thrown in there. So, let's look at this example. So these are clearly similar to each other because all three angles are congruent. All three sets of corresponding angles are congruent. But if you look specifically at where the tick marks are, they don't exactly line up. The orientation is different. So let's just come up with a hypothetical way we can transform ABC onto DEF. All right. So what do you think would be one transformation that would have to happen? Wait. Rotate. What do you think? How much? Close. I would say rotate 90 degrees but clockwise because you want this one on top. So you have to go backwards. So you were pretty much right. Just looking at the wrong triangle. So I would say we can start with 90-degree rotation clockwise. We're rotating. So if we do that, our triangle will look something like this. So here's A, C, and B. And again, I'm not drawing to scale, but I do know it's smaller than the other triangle. What do you think I could do next? You could translate it, all right? So you could translate it or you could dilate it. It just depends. So I'm going to say we're going to translate it first. And we don't know by what. It could be up, down, some, left or right, whatever. We're just going to say that we're going to do a translation somewhere in there. And what do you think the last thing's going to be? We would dilate by some scale factor. And we don't know what that is, but we do know that the scale factor will be greater than 1. Why would I say that the scale factor has to be greater than 1? Because we're going from a smaller figure to a bigger figure. So if it was between 0 and 1, it would make a smaller figure because it's a fraction. But if it was greater than 1, it makes a bigger figure. All right, and again, that's just hypothetical. It's just to kind of wrap your mind around that, yes, we can get similar figures from a sequence of transformations as long as a dilation is thrown in there somewhere. So this right here is what made those congruent figures similar. All right, we're going to skip exercise 3 because it's pretty much more the same as exercise 2. But let's look at exercise 4. So now they gave us a nice little graph. So, what scale factor do you think I'm going to need to dilate ABC so that its image is congruent to DEF? So it's not going to be right on top of DEF. We're not mapping it onto it. We just want to make those two triangles congruent. So what would be a method of how I can find what my scale factor is? So count the sides that I can clearly count, which would be which sides? A, B, and BC, as well as ED and EF. So AB is 4, EF is 2, 4, 6. BC is 2, 4, 6, 8, and EF is 12. Now, I don't really care about AC and DC because as long as we have one set of corresponding sides and we know that they're going to be similar because we're dilating, all right, we can still get the scale factor, all right? But having two sets is a good thing because it can also give you an idea of, okay, if similar figures, all the sides have to be proportional. That means that when we divide the two sets of corresponding sides, we should get the same number as our answer. All right. So, for example, what's two sets of corresponding sides here? 4 and 6. Now, since we're doing dilations, I have to do new divided by old. So I'm going to do 6 over 4. So if I simplify that down, what is that? 3/2. Now, that looks like it's going to be my scale factor, but just to check, I'm going to do the other set of corresponding sides and see if I get the same thing. All right, it never hurts to check. So I'm going to do 12 divided by 8. Is it not true that when I simplify that, I'll get 3/2? Yes. So 3/2 is my scale factor. Now, I don't really care about part B because I know you guys know how to graph that, do transformations, and put that on to the same triangle. So we're not going to worry about that. I more care about, can you get the scale factor? All right, because that's going to come back to haunt you a lot in this unit. Any questions on finding that scale factor? Now, another thing that happens is that sometimes similar triangles are created when a line segment is drawn parallel to one of the sides of the triangle. Now, this is not to be confused with mid-segment theorem, all right? What makes mid-segment theorem so special is that even though that line is drawn parallel to a side, it's drawn from the two other sides' midpoints. But what this is talking about is that they're just drawing a line connecting the two sides of the triangle, but they're not necessarily connected by the midpoints. All right. So even though this picture looks like it may be mid-segment, if you look closely, AD is clearly not the same as DE. Now you could argue it's not drawn to scale, but since we don't know for a fact that B and D are midpoints of their respective line segments that they're on, we can't say that BD is a mid-segment. We can, however, prove some similarity stuff. So if I look at this picture, it says that points B and D lie on AC and AE such that BD is parallel to CE. So these two lines are parallel. And they want us to give a dilation that would map ABD onto ACE. So in other words, we're looking at this tiny triangle that would map onto this bigger triangle. Now, first off, I just need to see if these triangles are similar. So, to check that, I'm going to make sure that the angles of each triangle, of both triangles, are congruent. So first off, this angle right here, angle A. What's true about angle A? It's reflexive. It's the exact same spot for both triangles. So we can say that that's congruent to itself. Now, what's another set of angles that I can say that are congruent? Use the 3 letters for these. So ABD and ACE. So we can say that these two angles are congruent. Why? They're what? They're not same side interior. If they were, they'd be supplementary. They're corresponding. Good. So remember, corresponding with parallel lines. Since these lines are parallel, we can treat this side as a transversal, and these will be in the exact same spot. Even though they're on the same side of the transversal, we can't say same side interior because, first off, this angle is not in the interior. Second off, remember, same side interior is supplementary, not congruent. All right. So these angles is because they're corresponding. It would. So it would be the exact same thing for these two angles, but now we're treating AE as the transversal, and they'd still be congruent by corresponding. And then just to recap, angle A is because it's reflexive. So even though that we know that we can do a dilation, this is clearly a dilation because ABD is similar to triangle ACE because all three sets of corresponding angles are congruent. Now, could we make up a dilation to make this work? Yes. All right. But, I mean, basically all this is saying is just be careful because a lot of times they love to give a similar triangle where there's one built into another. All right. So, the last thing we're going to do for this part of the lesson. So, based off of the previous triangle, they want us to find the proportion that is incorrect based off of the fact that those two triangles are similar. So, when you're setting up proportions, there's a couple of things you got to look for. You got to make sure that the corresponding sides match up, meaning that they can either be within the same proportion or next to each other. All right, so in the same spots of the two proportions. And you also got to make sure that the same triangles line up. So the sides that are from the same triangle line up, whether that's within the same proportion or within the same spot of the proportions. All right, and if that's a little confusing, you'll see what I mean in just a second. So let's just go through all of these and check. So our first proportion is AC over AB. So AB is here, AC is here. First off, are they corresponding sides? Yes, they're corresponding sides of the two triangles. Now, they then say that should be equal to CE and BD. So CE and BD, those are obviously corresponding sides. But what we need to check is to make sure that the way they stated the proportion matches the way they stated the first proportion. So if we go back to the first proportion, the numerator is coming from the bigger triangle, the denominator is coming from the smaller triangle. So the same thing has to be true over here. Is CE from the bigger triangle? Yes. Is BD from the smaller triangle? Yes. So this proportion is correct. So it's not our answer. Now, same thing with the angles. So angle A and angle A, so we know those match up at the very least. But now we got to check the other two angles. So angle ABD, and angle ACE. Are those two angles corresponding? Yes. So that proportion is true. Now, here's the next proportion. AD, which is right here, over AE. So is AD and AE corresponding? Yes. All right, so far so good. But then they have AC over AB. So AC over AB. Is AC and AB proportional? No, AC over AB. Is that proportional? It is proportional. They're corresponding sides. I mean, they're corresponding sides. That's what I meant to say. Are they corresponding sides? So yes, they're corresponding sides. But what's going to happen is, if you look directly across AD and AC, do those two sides come from the same triangle? No. So that right there is what makes that proportion incorrect. So this is the one that's incorrect. And then if you want to check the last one, it's just those two sets of corresponding congruent angles that you get from the parallel lines, and they set it up correctly. So that's why you gotta be really, really careful and attentive when you're setting up your proportions, because if you set it up wrong, you'll get the wrong answer. All right, now that's similar figures. So now let's look specifically at similar triangle criteria. So go to page 5 in your packet, and this is really quick. So, just to recap, similar figures have congruent corresponding angles and corresponding sides that are proportional. And a similar figure is a dilation of one figure that will make it congruent to the other figure. So, I'm going to skip exercise 1 because it's more of what we've already been doing previously. All right, so I don't think I need to cover that. So let's just go ahead and start looking at that criteria. So these are all the postulates that can make similar triangles. So just like how we have congruency postulates, so side, 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 angle, 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 side, and hypotenuse leg, there are also similarity postulates, but there's less of them. There's only 3. All right, there's only 3 similarity postulates. The first one is the angle criterion, which is AA. You may also see it as angle. You can either state it as angle or angle. The reason you can just state it as angle is because of the third angle theorem of triangles, meaning saying that if you have 2 sets of congruent triangles, then obviously the third set's going to be congruent based off the triangle sum theorem. All right. So either way you state it, it doesn't matter. So we're going to show that these 2 triangles, so again, this triangle and this triangle, are similar by the angle criteria. And they also told us that QR is parallel to NP. So we're going to kind of treat this a little bit like a proof. We're not going to do a full-blown proof, but what we're going to do is that we're going to state the sets of congruent angles, and then we're going to say why it is. All right, like what makes them congruent. So can someone give me one set of congruent angles? Abe. So angle MQR. What was the other one? It'd be. I wouldn't say Q and P. I would say M and P, just because it's for the whole triangle. So I would say angle M and P. So we're saying that these 2 angles are congruent. Why? They're corresponding. And we know that corresponding angles, so they're corresponding in parallel lines, which we know to be congruent. Someone else with another set. Wait. M and M. It's congruent to itself. Why? It's reflexive. So we can say that they are congruent because of the reflexive property. What's the last set? MRQ and MPN. So angle MRQ is congruent to angle MPN. And again, it's because they're corresponding. Now, we technically could have stopped after we got these 2. Because obviously by the third angle theorem, that third angle should be congruent to its counterpart. But I still wanted to show that all 3 angles were congruent just so we can see it. So because of that, we can state that triangle MQR is similar to triangle MNP by angle theorem. It just froze. Of course it did. Un momento. All right. So we can say that those two triangles are congruent by angle, angle. Not congruent, similar. Oh my gosh. It's Friday, y'all, I swear. Well, we're almost done. It's quick. This lesson's really quick. So, now, let's double check proportionality. So let's say MQ is 8, NQ is 6, and NP is 21, and they want us to find the length of QR. So let's call QR X. All right. So, do I have enough information to set up a proportion to solve for X? Yes. How would I set it up? I would divide by what? Nope. Okay, good. So the 6 is not the corresponding side to 8. So, but what is the length of the corresponding side of 8? 8 plus 6, which is 14. So I would start with the proportion that we know. So I'm going to say 14 over 8, and then set equal to the other proportion. So you could, but just for we can see where the proportions are, I'm just going to leave it as it is right now. But you could. The only problem is that if you do simplify it, there's room for error. So like if you simplify it wrong, it messes with your answer. So if you want to keep it okay, so we know that proportion right now is correct. And I know it's an easy simplification, but let's say it was like some really big numbers that was like, don't want to touch that. Then you just have to be careful. Okay, but you could totally simplify that. So how would I set up the proportion using X and 21? 21 over X. So since 14 is on top, that means 21 has to be on top. X is on the bottom. Again, you can totally simplify 14 over 8 to be 7 over 4. I'm just going to leave it as is just for right now. So I'm going to cross multiply, get 14x is equal to 168. So divide both sides by 14. What's x equal to? 12. So QR is equal to 12. So be careful with those because they do love to throw problems at you like that where they don't actually tell you the length of the corresponding side, but they give you enough pieces to get it. You just have to add them together. All right, so that's angle criteria. The other two is side, so SSS, which means all 3 pairs of corresponding sides are proportional. And side, so SAS. So 2 sides of one triangle are proportional and 2 sides of another triangle and the included angle. So remember, included angle means between the 2 sides is congruent. So not to be mixed up with the congruency postulates of side, and side angle side. All right. The difference is that the S's in both of those postulates, the sides, they're proportional, not congruent. All right, that's the difference. Angles still maintain their congruency. So we're going to go through and double check and see if these triangles are similar based off of the postulate that they want us to use. So for letter A, they want us to prove it by SSS. So side. So I got to check all 3 proportions to make sure I get the same number when I simplify. So what will be my first set of corresponding sides I need to check? AC and DF. All right. Now, it doesn't matter how you set up the proportion as long as you keep it consistent across all three of your proportions. So you could do small over big, you could do big over small. It doesn't matter. As long as it's consistent for all your proportions. So if you do small over big, that means all three of your proportions need to be set up as small over big. If you do big over small, all three of your proportions need to be big over small. All right. So I'm just going to do big over small just because that makes the most sense in my brain. All right. So I'm going to do I'm going to do DF divided by AC. So I got 6 over 3, which that simplifies to what? 2. What's the next proportion I can check? DE and AB. Now, since I did the big first, that means I got to put the big again in the numerator to keep it consistent. Because what happens is that if you don't keep it consistent, you'll find that they are different numbers. So you may think that they're not proportional, but in reality, you just flip-flop the proportion. That's why you got to be careful and keep it consistent. So that would be 10 over 5, which is what? 2. So far, so good. But just because those two have the same scale factor does not mean the last side does. So we need to check the last side. So that would be FE over CB. So 8 over 4, which simplifies to 2. So since all proportions are the same, we get the exact same number when we simplify. We can say that triangle ABC is similar to triangle DEF by side, side, side. So that's how you use side, side, side. You have to check all three proportions if you're using side, side, side. All right, you can't just do 2 and be done with it, because there are very rare cases where that third side is not proportional. Now, side angle side. First off, before we even attempt side angle side, is that angle the included angle? Meaning it's between those two sides. Yeah, it is. A way you can remember it is that the included angle is always the angle that's made up of the two sides we're given. So like these two sides make that angle. These two sides make this angle. All right. Now, are those two angles congruent? So is angle ABC congruent to angle DEF? Yes, they are. They're both 110. So those two angles are congruent. So I know the angle is congruent. Now I got to check to see if the sides are proportional. So I'm going to do DE over AB. So that's 15 over 10, which simplifies down to what? 1.5, or as a fraction, 3/2. Then I'll do EF over BC. So that's 21 over 14. Does that also give me 3/2? Yep. So my two sides are proportional and the included angle is congruent. Thus, we can state that triangle ABC is similar to triangle DEF by side angle side. All right, last thing and then we're done. So we just want to go through and make sure. So they're asking us which of these 4 choices does not prove that those two triangles are similar. All right, so let's just go through each one. So the first one, they said that. So first off, so we know what the corresponding sides are. Remember, you can always look at how they name the triangles. They always name two triangles the same based off of their corresponding sides and angles. So whatever the order is, it should be the same order for the other triangle. based off of what's corresponding. So S is congruent to B. Is S and B corresponding? Yes, because they're both the middle letter of the name. All right. Even though the orientation is a little wonky, we can still see it. And then C is congruent to T. Is C and T corresponding? Yes. So do I have enough information to show similarity? Yes. By what postulate? AA. So that one's out. Now, they then said AB is over RS. Are those two corresponding? Yes. And it should be equal to AC over RT. Is AC and RT corresponding? Yes. So we have two, and they're saying that those proportions are equal to each other. So that's two sides that are proportional. And they said that angle A is congruent to angle R. Are those two angles corresponding? Yeah. So do I have enough to prove? Yeah. By what postulate? Side angle side. And again, we know this because if I actually went through and marked this, here's AB, here's RS, here's AC, here's ST. And that angle, oh, that should be RT. And that angle should be between those two sides. So just because they give us two proportional sides and two angles doesn't mean it's side angle side. You still got to look at the placement. Now, the third one is obviously yes, because it's obviously side, side, side. They're saying all three sides are proportional. And the proportions are correct if you look at them. The fourth one, though. So they gave us the sides RT and AC. They also gave us the sides TS and BC. And then they gave us the angle B and S. Is that enough to prove similarity? No. Because the postulate that's actually showing is the one word that I said we do not want in this class. It's SSA, which you can spell that backwards in your head all you want. All right? SSA doesn't prove jack diddly. Okay? It doesn't prove congruence. It doesn't prove similarity. The only exception to that rule is when you're dealing with hypotenuse leg. But for the most part, the jack diddly. So at no point I should ever see you guys put SSA as a postulate to prove anything. So 4 is your answer. All right, so your homework for tonight is pages 3, 4, and 7 and 8. So your homework for tonight is 3, 4, and 7 and 8. And I will be checking it on Monday. Yeah. So that's your homework for this weekend. Now, you can also use this time to work on those delta math. So I know that some of you had questions with the proof ones. If you have those questions, you can come see me during this time now. You guys got a solid 25 minutes? That's the only one. So there's no new delta math. It's just the paper homework for this lesson.
Do we have to write out everything?
Let me see it. I'm not looking at it. I'm a visual person.
So for ones like this, do we have to write out all the sides and how they're going to do it, or can we just write it?
Well, it's just asking you to find the other side lengths. So if you can find it, then you can set up the proportions to find the other two.
Okay. I mean, I know how to do it. I just
Yeah. I mean, you're not actually showing similarity because they already said it's similar. So you don't have to, beat a dead horse. It's already there. So just figure out what the scale factor is and then go with it. By the way, guys, your journals are graded. Good job on this one, but I will hand them back Monday.
That sounds great. Did you go to school here?
I went to Havelock.